I'm going to introduce our next speaker here, and first speaker for the afternoon session. And this is Katie Bach. She's a senior principal systems engineer at Medtronic. Katie?
Great, thank you. Working? Okay. Hi, like Ken said, I'm Katie Bach. I'm an engineer at Medtronic. And I kind of want to start off with a few questions just to see how much you've been paying attention today. Actually, first to get a feel, before coming into the conference today, how many of you had heard about deep brain stimulation or brain modulation to treat Parkinson's or essential tremor movement disorders? All right, a good percentage. How many more hands go up after this morning? Let's see a show of hands. All right, a little bit. I wasn't sure what all different talks you saw this morning. Okay, so when we talk about neurological disorders, a lot of times we think about the place to treat them is the brain. But the nervous system is obviously complex and spans the whole body. So there are actually a lot of treatments that can be done by stimulating nerves in other areas as well. How many of you have heard of spinal cord stim to treat pain? Excellent. What about sacral stim for bladder and bowel control? Anyone? One? Two? All right, good. Yeah, so as you kind of saw from the numbers there, a lot of these things are not very well known, even though they might be really powerful options for people suffering from various pretty debilitating conditions. And so I'm really lucky to work for a company, Medtronic, that's committed to innovating and focusing on how do we bring these life-changing therapies to people who could really benefit from them, and also lowering barriers to adoption. There's a great question out in the lunch session about what's the accessibility of a therapy like this. And that's really important too, because if there's a therapy out there but you can't get it because your doctor doesn't know about it or your insurance won't pay for it, it's no good to you then, right? You can't benefit. So, it's really exciting to me to be kind of, at a company that isn't just focused on what is the therapy, but also how do we get it into more people who could benefit. Forgot to get my clicker going here. So, some of you who had heard of DBS may have seen this video before. We'll see if we can, or may have seen a similar video before. Let's see if we can get it to play. Nope. All right, I'm not going to try to worry about it, but you can find similar things on YouTube. So this video is showing a patient that had pretty severe, does have pretty severe symptoms of tremor when living with Parkinson's disease. And you can see that when they turn on their brain stimulator, he's able to get up and walk almost normally, whereas before that, you can see he needed assistance even to stand because he was shaking so badly. And so it's just one example of, kind of the powerful impact that some of these treatments can have, and it's so inspiring for me to be able to work on systems like that. So how did I get here? So I went to high school in Michigan, Chelsea High School. My favorite classes in high school were physics and calculus. I really loved learning about how things work and making sense of the physical world that kind of came through and opened up my eyes in my physics class. But I didn't know what I wanted to be when I grew up. I didn't really have a sense of what options were out there. And it was actually my art teacher in high school who suggested I consider engineering, because he said, you're really creative, you like art, and I did. I love art still, and doing things with my hands especially. And he said, and you've got, you like math, you like physics, you should consider engineering. And that kind of opened my eyes. And to be honest, actually my dad's an engineer, and for some reason it still didn't occur to me that was a thing I should consider or learn more about. So I went to the University of Michigan in mechanical engineering, and really loved, like I said, doing things with my hands, physical, understanding the way things work. Some challenges I had in college was really, well, for me, learning how to learn. I was used to kind of absorbing in high school what my teachers were sharing and kind of doing my homework and understanding the concepts through doing homework. And in college, I had large lectures, a lot less sort of personalized attention that without seeking it out, nobody's really checking in on you. So I learned to use office hours, use the graduate student instructors who are there to help you, use my peers to talk through things together and understand and realize that we're all kind of in the same boat, trying to understand the concepts. That being said, I also dealt with some, I was intimidated by some of my peers who came into an undergraduate engineering degree already having had, a lot of experience in high school, whether they were in a CAD class or a robotics team. They kind of already had, some experience of doing things with, tools and some of the software we used and things, and I didn't know any of that. But what I learned was it doesn't matter what you come in with, it's how you approach learning and how you, I realized okay, just because I didn't know it already doesn't mean I can't learn it now. And so, really had to build some of that self-confidence to know that, I belonged there and that I could learn how to do these things too. So I had a few internships out of my undergraduate degree where I first worked for GE Healthcare in Waukesha, Wisconsin, and that kind of opened my eyes to the fact that the medical industry actually is a great place for engineers, and that it was an industry where I could apply my interests and help people, and that really kind of struck me as where I belonged. And so I focused my master's degree, it was still in mechanical engineering, but I kind of focused it toward biomedical applications, and then came to work full-time for Medtronic after my master's degree. And, okay, I'm gonna ask another question, keep you guys awake here after lunch. How many of you have heard of the discipline of systems engineering? A few. All right, well, you're more ahead. I went through 5 years of engineering school and had never heard of it until I was called to ask if I wanted to interview for the job at Medtronic. So it's a very interdisciplinary function, which I'll get into a little bit more. And I really enjoyed my first job there, but I also realized that I'd gone to school for mechanical engineering and I wasn't getting much direct experience in that. So I moved to a mechanical design role in our neuromodulation group, and I did some work there, and then transitioned to what we call a product engineer, where I was kind of the owner of the technical solution for an entire kind of implanted device, and then just recently, about a year ago, moved back into a systems engineering role in our neuromodulation group. One of my hobbies is FIRST Robotics. I mentor and volunteer with FIRST. Any show of hands, anyone involved in FIRST? A few, excellent. And I love being outside. I play ultimate frisbee, broom ball, like being active. So, talking a little bit more about what is systems engineering. Like I said, very interdisciplinary. It's a role where I'm integrating all these different functions and different stakeholders and experts in different fields to bring a solution from idea stage to fully market released and available to patients. And so that involves a lot of different topics and a lot of different fields of engineering. You might imagine, of course, to make a neurostimulator, you need mechanical design, who's making the materials and the parts and the manufacturing. Going along with that is reliability. How do we test our devices to make sure that they're going to last for 15, 20 some years implanted in the body with, you can imagine, all of the different forces and constraints that are applied on a pretty harsh environment. But some you may not think of quite so obviously are things like the FDA labeling, our regulatory submissions. Obviously, electrical engineering is a big part of what we do in our neurostimulation group, especially. And you got a little teaser or flavor of that in the lunchtime talk as well, of what type of signals are we sending and where are they going and what is the right amplitude and frequency that we should be applying these signals. There's also a big aspect of user interface and software design. So our neuromodulation systems consist not only of an implanted device and an implanted lead that goes to the target nerve, but also a lot of times a clinician tablet that has a software on it that controls the device and sets up all the parameters. And often actually a patient handheld device as well, so that they can turn their therapy down or off or adjust their settings to optimize their response. So all of the user interface and human-centered design that goes with that is a big field. And then clinical and research. So there's a great continuum from you got a sense this morning of academic research and exploring brand new ways of how do we treat conditions in different ways, applying existing technologies or new technologies. And there are a lot of great partnerships that Medtronic does with a lot of institutions, including University of Minnesota. And then we also have our own in-house research where we kind of are taking the next layer to do studies on both humans and animals to understand different ways to apply these technologies. And then running clinical trials. So as we get to, what does it take to scale up? And, how do we prove out efficacy and get to a point where we might be able to get insurance reimbursement for something? That's all part of our kind of clinical research pathway. And so my role, sitting at kind of the center of all that, is really making sure that everything works together. That when we have, our mechanical design and our electrical design working together, what are we going to test? How are we going to make sure that our system is working the way we designed it? So I own the technical strategy, and then, also how we portray that technical solution to our customers through our labeling, through our regulatory submissions, et cetera. So my day is highly varied. I might go from being in the lab, troubleshooting something, why are we seeing this when this button is pressed, to, the next hour I'm giving a presentation to our senior leadership about why we should, start a new project and what's the value it's going to bring. I might then run back to my desk to review some marketing materials to make sure they're factually correct before we use them out in the public. So a lot of fun, a lot of great challenge, it's a great, feels like to me a great place to use my technical skills and my understanding of how things work, as well as my communication skills and leadership to make sure that everyone understands our system and is working together on it well. So I'll close with just a couple thoughts. So engineering or, the adjacent science and math and everything can feel really hard and really complex. An engineering degree, to be honest, is not easy. It's a challenge to learn all of these concepts and really understand what's going on. But fundamentally, embracing the mindset of an engineer, in my mind, is asking two questions. How does this work? And how do I make it better? And that is, if you keep that at the forefront, and regardless what field you decide to go into, you're on your way to making the world a better place. So thank you. I think we have maybe 1 minute for questions. Thanks. Any questions out there? All right, well, if not, I will introduce, or maybe hand it over to Ken to introduce my colleague, Keisha.
Thanks a lot, Katie.